Okay, and if Liam's batting third, and if he hits a shot that gets robbed at the wall, then we know that Jeremy will be batting fourth to drive everyone else in. Now, here's this kind of builds off the idea of permutations. All right, so let's say you have the word Mexico, all right, and you'll see why I chose the word Mexico. How many ways can you arrange those letters, right? Well, of the 6 different letters, any of the 6 can go first, and then so once you choose, like let's say we put X first, all right, then any 5 letters could be the second letter, and then any 4 letters could be the third letter. Then you got 3 left to be the fourth letter, and then 2 left to be the second to last letter, and 1 left to be the last letter. So there's 720 ways to do that. All right, but Mexico is our neighbor to the south. What about our neighbor to the north, Canada? How many ways can we rearrange the letters of Canada? Well, you might be thinking it's just 6 factorial. How is this different than Mexico? Well, Canada has repeated letters. Notice how if I switch any of those A's, if they weren't colored, you wouldn't notice. If I switch the green and the blue A's, it still spells Canada. All right? So if we look at, let's say we did this, NADACA. Well, there's just 6 different ways to do that, and it's all the same word. So this is kind of like in between a permutation and a combination, right? Order matters for the N, D, C's, and the A's, but amongst the A's, order doesn't matter because it's just a letter. And my name's Adam. If I switch the first and third letters in my name, it's still Adam. It doesn't count as a different, like I wouldn't count them as 2 different names. So what do we do here? All right, this is called a distinguishable permutation, or known on the streets as the Mississippi rule, because Mississippi is a word that has a lot of repeated letters. So when you have repeated elements, it doesn't have to be letters, but if you ever have a word problem that you could represent like this, like represent as a word, and I'll explain what I mean, you should use this rule. All right, so you take the total elements and you do n factorial, and then you just divide by n1, n2, n3 factorial, where those are how many times each thing repeats. So like for Canada, it's 6 factorial because there's 6 different letters, and then 3 factorial because there's 3 A's, and then if you wanted to, you could do 1 factorial for the 1C, the 1N, and the 1D, but like this part here, it's all 1, so it doesn't matter. So that would represent the number of ways you can order the letters in the word Canada. Now I just mentioned that this is called the Mississippi rule because Mississippi is like a good example of a word that has a lot of repeated letters. So if you want to try this one real quick, pause the video. And then here's how you do it. So Mississippi has 11 letters. 4, oops, why is that not writing? Alright, so it's 11 letters. Okay, now M repeats once, I repeats 4 times, S repeats 4 times, and P repeats 2 times. So this represents the number of different ways you can order the letters in the word Mississippi. And if you wanted to do that on a calculator to see what that equals, here's how you do it. Okay, so for this I'm going to hit Control Division and type in 11 factorial in the numerator, and then 4 factorial in the denominator, and then just keep doing that, times 4 factorial, and then times 2 factorial, and we get the number of ways to order the letters in Mississippi. Now, there are other ways to do this, specifically using combinations, which I have not gone over yet. So I'll try to reference back to here and show you another way to do this, but just reiterate my PSA at the beginning of this video series. In this section, there's a lot of ways to do it correctly. Like the same question could be done a lot of different ways, so don't let that be something that confuses you. It certainly might, and that's okay, but just because you're thinking about it a certain way doesn't mean you're doing it wrong. Ultimately, we should get the same answers. And if you're not sure why you're not getting certain answers, just ask. But just keep that in mind, that there's a lot of different ways to do these. Okay, now combinations are just like permutations, except it's when the order doesn't matter. So again, think when you're choosing a committee, you know, when you're choosing like a committee of people that all have equal power, it's like you use a combination, committee combinations. Permutation, president, vice president. If someone's a president and someone's a vice president, that's different than if you switch those two people. All right. So the only thing different is we just have to divide by r factorial. Other than that, it looks just like a permutation. And you don't really need to ever do this because you'll always have a calculator doing these. And you just type in NCR, and you type in, all right, if I want to take n things and choose r groups, size groups from those n things, you're going to type it in the calculator like that, and I'll show you. All right, so in poker, how many 5-card poker hands are possible? So if you ever got a royal flush in poker, it's pretty crazy because that's very unlikely because there's so many different ways you can order these cards. But one thing in poker, if you've never played, is that the order doesn't matter, right? So a royal flush is when you get, let's say, an ace of diamonds, 10, jack of diamonds, queen of diamonds, king of diamonds. Now it's a straight. It's a variation of a straight, which means like here would be a straight, like 4, 5, 6, 7, 8. So that's 5 cards in a row. But if you receive this card first, and then this card, and then that card, and then this card, and then that card, it's still a straight, even though you didn't receive the cards in order. So that's what I mean by order doesn't matter. As long as you get these 5 cards were given to you in any order, you have a royal flush. So how many 5-card poker hands are possible? Well, there's 52 cards. Choose 5 of them. Okay, so let's see on the calculator how many cards that is. Okay, so there would be about 2.5 million different possible 5-card poker hands out of the 52. Alright, and that's the same thing as doing 52 factorial over 47 factorial divided and also over 5 factorial. That would come out to the same thing. So that's, if you play 2.5 million poker hands, there's chances are you'll get 4 different royal flushes, 4 from each different kind of suit. But that's a lot of hands.